Hi guys. Before I start, I'm wondering, are you programmers or are you sysops, DevOps stuff? So, if you're a programmer, raise your hand. Yay, programmers. Oh yeah. And another thing I want to ask, do you prefer lower languages like C, C++ and stuff, or Haskell, Clojure, and whatever you? So if you like C, raise your hand. And if you like Haskell, then yay. I want to know my audience before I talk. It is probably time to introduce myself. I'm Igor, and I write software, so I'm a developer. But I actually know a lot of stuff about Linux, and fun fact, I've been using, I think, Gentoo and Arch for the last like 15 years, so I know my way around. Maybe not Arch, because Arch actually came out later, and I work with some awesome people. I don't know if you know any of these people, and we write software that is called Sanfor, and it is a hosted CI service. CI service is like a continuous integration service, and basically that means that whenever you push something to GitHub, we build something. Whenever you merge, we deploy. Whenever so on, and that means that we usually have like around 100 or maybe even more jobs per day. That means we need to run that many virtual machines, that many processes need to be fixed. And one thing that is really important for us is that we can't really support errors, or we can't really let them happen. Even if they happen, we must be fault tolerant. We must fix the issues because our customers want to like have a stable system and so on. But as you know, when you run a CI service, you're basically letting someone else code to run on your machine. That means your machine needs to be safe, your machine needs to be secure, your machine has to be fault tolerant in all kinds of ways, because there are a lot of people and they try a lot of stuff like mining bitcoins and I don't know, so a lot of things I have experienced. But even if we really try to avoid all of these errors, they unfortunately happen, and in the background actually they happen a lot, but our system is designed in a way that we somehow retry and silently process again all the errors that happen. Because some errors we just can't control, like errors in the hardware, like memory issues or hardware or hard disk issues and stuff. And so our code must be resilient at any point, and this talk will be about that and our journey from Ruby. So we basically started with Ruby on Sanfor and have been using it for like, I think 8 years. But at some point we figured out that Ruby is great and it lets you be happy in some way and lets you write code that is somehow feels good, but it is not the most scalable and the most secure thing out in the world. And with this, we really love Ruby. So if you're familiar with Ruby, we have probably used all the things that you can imagine. We have used Rails and Sinatra, Capistrano for deployment. We used Chef for provisioning and Psychic for background jobs, RSpec Cucumber for testing, and so Postgres, Rabbit, Redis, and all the usual stuff that are somehow a main part of the Ruby ecosystem. And as you probably feel from my talk, Ruby has some superb tools if you are starting out your company, and it probably has one of the most awesome communities out there. Even if you don't use Ruby, you probably need to recognize that yeah, those people are trying to do their best, and they are real helpful. And one important thing with Ruby is like it is treating us like human beings. That means that you don't need to write for loops everywhere, and you don't need to write indexes and stuff like that. So it is mostly a functional programming language, but it really isn't. So, but at this point, I think last year or 2 years before this, we had quite a lot of trouble with Ruby. And one of the main issues was that our background processing, so the heart of our system, that is called Psychic, died really often. And so if you use PagerDuty or something like some calling mechanism that will call you, it usually broke in the middle of the night, and we had to wake up and stuff like that. And then, of course, because we are using Ubuntu in production, we wrapped it in like many upstart scripts. Even if you die, you will restart and timeouts and so on. And we have tried our best, but the main issue with upstarts and stuff like that is it's like really hard to test. You need to test it manually, so whenever you change that script, you have to run it, and you probably need to restart your server and so on. And ideally, you want to write some automatic tests that will like automatically test that behavior. Another thing with Psychic was that like every time your process dies, it needs to be respawned from the start. That means it needs to fill the memory and boot all the things, and that can like be a 5-minute process. That means that our system is 5 minutes down, and if our process is 5 minutes down, that means we potentially lost like tens or thousands of jobs. And of course, it used too much memory. If you ever used Java or Ruby or something like that, you probably know that all of the things that are like easy to use probably use a lot of memory in the background. But yeah, at that point we like one thing that we had to realize is we need to have a lot of Psychic processes, and every Psychic process needs to have its own upstart scripts. And again, writing upstart script is hard, testing this is hard. If you have multiple of those, and if they are different, then it is even more harder. And one thing that we introduced is something called Inspector. So it manually checks your memory and CPU usage and stuff like that, and automatically kills your processes whenever something bad happens. But it is a good system that it keeps the overall system alive, but in some sense it is just plugging out the connection from the service and letting it restart automatically. And at that point, so this whole talk was about like resilience, but also we had a lot of like need to run parallel processes, and we needed to create parallel processes and jobs like really easily. We don't want to write new thread or semaphore or synchronize every time we want to do something, because we need to have like a lot of those background things. And yeah, we wanted a system that is somehow easy to parallelize. And for example, in Ruby, it looks like this. So if you have a build with many jobs, and at one point you can say create a job request. This code is sequential, so it will create one job request per iteration. It looks basically like this. And so each of one of the green things is like a job creation. And yeah, this is obviously slow. This is 5 seconds. We wanted to minimize it. For example, 1 second is acceptable. And at that point, I think I or someone else from my team was like, yeah, we will use like new thread and parallelize everything and hope for the best. And that means let's use pmap, paramap. And we got something like this. So they were parallel in Ruby, but like they took the same time, and it's like the basic pointer that you need to change something in the core of your system because you want to create threads easily. And yeah, we were having this reaction to the whole thing. And this is what we actually wanted. And at that point, we have like scouted out for new languages or new platforms or something like that. And for example, I'm a huge fan of Haskell, and some of my colleagues are huge fans of Clojure. But neither of those platforms had the things that we really wanted, like easy parallelism, good stability, and to be fast. And yeah, of course, we wanted something fun and fast, and that one big requirement was also to be fault tolerant. So we wanted our platform to be fault tolerant by default, and we don't want to think about fault tolerancy ourselves. And we want a system that has cheap threads. And at that point, every platform that we looked into, Erlang was somehow an obvious choice because every telecom company is using probably Erlang. And I don't remember that there was any time in my life when I like wanted to send an SMS and it failed. So they have a really good fault tolerance system. And if you're into fault tolerance, you probably need to look into telecommunication and the Erlang virtual machine. And yeah, Erlang was fine, but the language itself is a bit like old, and I think it's a variant of Prolog, and Prolog is also like fun, but you don't really want to write production system in it because it's not easy to see the performance issues or something just by looking at the code. And at that point, we looked into a new language that is called Elixir, and Elixir uses the Erlang virtual machine in the background. So we were like, yay, why don't we use this? And so one of the obvious things, the Erlang virtual machine is really battle tested, and I think you can achieve like 99.69 or 10.9 uptime with it easily. It is a pure functional language, so it's easy to write maps, filters. You don't have shared data or non-immutable things, so it's very easy to write code because you don't want to write for e equals 1 and so on. It has macros, so my need for macros and my love for Clojure can be used here because I really want to use macros. And probably the one good thing is it has like agents and these gen servers that are like processed in the standard Linux in the standard Linux environments, but they are encapsulated in this pure functional style that it's easy to manipulate. And one big huge win for us was that Elixir looks like Ruby. It doesn't act like Ruby, but it looks like Ruby. And when you switch from writing Ruby every day and you want to write Elixir, another language every day, it's a good thing that, yeah, I can take an array and do map to squares, and I can do this in the new language, and it's like very easy to jump from one code base to another. And for example, in my case, I think I have picked up Elixir like in an hour, and I was like writing my first application, and I was happy, and so it's a good thing. And yeah, so I have said a lot of good things about Elixir, but how it turned out in practice. Well, we really like to use Docker and microservices, and writing microservices in Elixir was like very straightforward, because when you write like, I think, mix new, that creates a new project that can be very, very easily packaged into a small container that you can just push to whichever server you want. At Ruby, we used to measure our system with milliseconds. So like this action took like 100 milliseconds, and we were like, yay, 100 milliseconds. It's almost not noticeable. And when we switched to Elixir, one thing that was like obvious is Elixir starts to write out like your action took 100 microseconds, so it's like 10 or 100 times faster by default than Ruby. And it's like, whoa, I'm writing the same code and I get a huge benefit. The language itself has something called supervisors. It means that if you have n services that are running in your application, you can define one supervisor that will supervise all of these things, and whenever something dies or runs out of memory or some weird error occurs, it just stops that process and restarts it. And it was a huge thing, because previously to achieve something like that we used Upstart, and like I said, Upstart was okay for like running Postgres. You want to run Postgres with Upstart and restart it, but if you want to run like thousands of these background processes, you don't really want to write Upstart, because it's really painful. So the language itself is fault tolerant. All the Upstart scripts were refactored to some supervisors. And a huge win with supervisors was, of course, that if you write a supervisor, you can actually write a test that will like kill some of the processes in the system, and you can test if the supervisor automatically restarted those processes. And it was like, whoa, I can write it with a simple test, and I don't need to restart my server, and I don't need to do some really weird stuff. And yeah, so that was the very good thing about writing code with this. But at that point, we wanted to deploy it somewhere. And a big difference from Ruby is that Ruby is somehow accepted everywhere, and you can very easily find a server that will run your Ruby script or your Ruby application. But it is much harder to find a ready production system that will run your Elixir code. But on the other side, on the other hand, Elixir compiles into one binary that you can just like put on your server. That's also a big thing compared to like PHP or Ruby, when you have to like clone the whole repository on your server to run it. And you can run it with a simple tar.gz. You untar it there, start it, and it basically runs. And at the same time that we started to use Elixir, we started to use Docker. And of course, with Docker, it is really important to have like small self-contained things that are with a big emphasis on small, because a Ruby application can be, for example, 3 gigabytes. And if you want to put 3 gigabytes in a Docker container, then upload it. For example, we want to upload it from Serbia to, I don't know, a server in, I don't know, Brazil. Then I need to wait those 3 gigabytes to go over the wire. And it's like, I need to wait 15 minutes for something to happen. That is not ideal. I want to have always, like, I want to click something, wait for 1 minute, and I want it to be finished. But with Ruby, it was really hard because, yeah, it doesn't support like small self-contained things. But with Elixir and Docker, it was actually really nice because an Elixir application can be up to like 5 megabytes or something. Sometimes it can be bigger, but usually it is like 5 or 10 megabytes. If you put it in a Docker container, for example, in an Alpine-based Docker container, you can get something like a 30 megabytes package that does the same thing that the 1 gigabyte Ruby application does. And you can upload 30 megabytes in a matter of seconds compared to like 10 minutes or 15 minutes with 1 gigabyte. And I have said a lot of good things about Elixir, but there are, of course, a lot of downsides. For example, with Ruby, you usually have a lot of out-of-the-box solutions. Of course, with Java, this is also true. So if I want to like have pagination on one of my HTML pages, it's like I just install something and it works. In Elixir, you usually have to like hack it yourself or do it yourself. Another thing was like metrics. We used, I think, Librato for metrics, and at that point we figured out that, oh, Elixir doesn't have a client for that. We use Sentry for exceptions, and then we figured out that, oh, Elixir doesn't have support for that. But we somehow believe that we can write those client libraries ourselves. And basically, we have fallen back to the old principle. We forked something on GitHub, improved it, used in production. Another big issue with, I think it's not just the issue with Elixir itself, but the switch from statically compiled, or compiled languages to interpreter languages was like in interpreter languages, whatever configuration you have, you probably can do a lot of manipulations, and your configuration is basically just another script that runs. But if you have a statically compiled something, you probably have just simple strings that you can load into your program. And it was a big hurdle to overcome at first, because you don't really know what to do at that point. But we have come up with several like things. We used environment variables for configuration. But yeah, so at this point I just want to wrap it up. And so big things with Elixir are stability and scalability. That was somehow out of the box when I compared to Java or JavaScript or Ruby, that it's not really out of the box. Elixir is often an awesome replacement for microservices that are written in Ruby. There are, of course, really good projects in Elixir world, like Phoenix and Acto. Acto is a database wrapper that basically can talk to any database out there. That was a big thing because we didn't want to fall back to writing raw SQL or raw, I don't know, Redis commands. And Phoenix was like a replacement for Rails. That's also a very good thing. And that's all. So I have been probably a bit fast, but we can have some questions if you are interested. So, any questions? Anything? Yeah? Maybe you can.
Have you investigated the problem with parallel maps in Ruby? What was the actual problem?
Yeah, well, it is a known issue. Languages like Python and Ruby don't really support true threads, but they have a global interpreter lock, so only one part of your code can execute. But they provide they can work with I/O parallelly, but they can't execute a part of code in parallel. So that was a big thing. Of course, there are projects like Rubinius, and in Python world, I think it's called. I don't really know Python still, but I know there are some projects that can overcome this issue. More questions?
Do you have some experience with Phoenix channels?
Yeah.
Have you used Phoenix channels in production? I know there is the active channels in Rails, and it's quite it's a hack basically. So I'm quite interested how it's working in the Elixir world.
Well, the implementation is similar, but the big difference is the Elixir channels are actually working. That is a big thing. We still mainly use some other WebSocket services to communicate or push some live changes to the HTML pages. But yeah, we have started to use channels, and so far they are stable and they are quite fast. That's only so we haven't found any obvious bug or issue with them until now. But we will probably find some bugs when we run like millions of open connections parallelly. We use, I think, a Haskell-based solution for some channels.
What about testing in Elixir? It's not so common to test functional code, but...
Well, I'm not sure if it is not common to test functional code. At least from my experience, Clojure people and Elixir people and Erlang people are really into testing, usually. So not all of them, but usually the code is well tested. Not in a sense like, is this a string or is this something else, but you want to write some functional test. If for example, this kind of payload arrives, will my service convert it in some meaningful way, or will it write to the database in some meaningful way, or something like that. And yeah, in Elixir you have like the standard X unit that is very, maybe I can even show you on an example. Then, so the tests are like test, do something, and then assert. So basically very easy to write them. This code is it's a bit messy because we are running in this test the Docker container and smoke testing it and everything. But yeah, so also there are those things like inline documentation test. So whenever you write a piece of code, you can write a doc string above that. You can write some examples, and when you push the documentation, all the examples are executed and tested if they are like correct, and it's a big win for open source projects because various people write various documentations that are sometimes not the best.
How did you manage to get around this static configuration problem and your configuration over environment variables?
So the first issue was, I think you said you actually use Elixir in.
I have this problem.
Yeah, so in a standard mix project, you have config something, and you can write some things, but they are injected at compile time. We have found one hack, I think. You can use relics, Elixir Erlang replace. So whenever you, I think I can show you an example. So it's config. So if you like have this kind of string, and then you can say relics replace with that string with an environment variable when the application itself starts. That was this is of course a hack, but it works. Another solution that we are looking at is we are maybe trying to switch from AXML, that is the standard packaging thing, to Distalizer, that is the new thing, and I think it supports some more advanced configuration things. And the final thing that we used is like write a module that is called configuration, and you load the things yourself. So yeah, we mainly use environment variables because they are somehow more versatile and easier to use than configuration files. But yeah, if you want to use configuration files, then of course you can load them.
It's easier to deploy with Ansible, for example.
With? Yeah. We of course don't use Ansible, so. Yeah. Any questions? That's it. Thanks.
Of course. I don't know the audience because we have like I have like a REST API that's using Gen servers as backend services. And in testing, I want to, use one database, I don't want to configure, always configure for every Gen server one database. I just want one database configuration and say, all Gen servers use the same repository. Do you know how to solve this problem? I think
that's out of the box, I think, or maybe I'm wrong.
I don't know, because we just started using those backend processes, and
so in my experience, you have like repo, active repo, that is itself a Gen server, and all the other Gen servers are like communicating with that, and you don't really need to share them explicitly. It's by default like that.
Okay,
I think.
Okay, I can just open one repository and share the process with all the gen servers.
Yeah.
Okay.
So
Yeah.
idea is the act repository itself is a process,
Yeah.
and you just communicate with it.
Yeah.
Even if it's on some other server, Erlang can take care of that if you pair them up correctly. So you probably don't want to communicate with other repositories on other servers because it is slow, but yeah.
So, and what about the migrations?
The migrations, so you probably run into the issue that mix is not available in Elixir.
Yeah.
And so we run our migrations by, the first thing that our application does is run the migration. Then it starts the gen server. And so we don't use gen mix tasks, but we actually write call the act to migrate API.
In the startup sequence of the
Yes,
gen
yes.
server. Okay.
So that was a big issue for me also, and I have written, please help me, message on the Google mailing list, and I think Bitwalker and Jose Valin replied to like it's intended to be called from the code.
Okay, cool.
So
Thank you.
that's it.